Hey, welcome to The Explainer. You know, we're all just getting our heads around 5G, but today we're going to leap forward, way into the next decade, to look at the next wireless revolution. It's called 6G, and it promises to build a world that's not just connected, but completely and seamlessly woven into the digital universe. So, is 5G already history? I know. That sounds kind of crazy, right? It feels like we just got it. But here's the thing about technology. The very second one standard is rolled out, the smartest people in the room are already designing the next massive leap. And the simple truth is, the world we're heading towards in 2030 and beyond, it's going to have needs that even today's best 5G just can't meet.
So what's the big rush? Why even think about 6G right now? Well, it all boils down to one absolutely massive number: 100 times. The International Telecommunication Union, these are the folks who set the standards. They project that by 2030, our global hunger for data will be 100 times greater than it is today. That's not a wave, that's a data tsunami. And our current networks, they're just not built for that.
So here's our game plan for today. We're going to see just how huge this leap from 5G really is. Then, we'll dive into the wild new network architecture and the future tech that could make it all happen. We'll spend some time dreaming about what life could actually be like in a 6G world, and then we'll come back down to Earth and get real about the massive challenges standing in the way. Okay, so first things first, we need to get one thing straight. 6G is not just going to be 5G+. This isn't a small step up. The performance goals we're talking about represent a genuine quantum leap, a massive improvement in pretty much every way you can measure it.
And look, that 100x number, it's back again, but for something totally different called connection density. A really good 5G network can handle about 1 million connected devices inside a single square kilometer. 6G is aiming for 100 million, 100 times more. Now, this isn't about more smartphones. This is the foundation for a true Internet of Everything, where every single traffic light, every car, every sensor in an entire smart city is connected all at once.
And yep, you guessed it, that 100x multiplier pops up one more time for the thing we probably care about most: raw speed. Right now, a really solid 5G connection might get you 100 megabits per second. The target for 6G? 10 gigabits per second. That is another 100-fold increase. I mean, just try to imagine downloading dozens of 4K movies in the blink of an eye. That's the kind of speed we're talking about. And then you've got latency. You know, that tiny annoying delay between when you click something and when it actually happens. 6G's goal is to crush that down to just 0.1 milliseconds. That's 10 times faster or lower than 5G's goal. It's a speed so fast, it's basically instantaneous to us humans. And that's absolutely essential for things like remote robotic surgery or brain-computer interfaces, where even the slightest delay could be a disaster. So let's pull all this together and look at the big picture. You can really see the scale of the ambition here. We've talked about the user speed and that crazy low latency, but look, the goals go even further. We're talking peak data rates hitting 1 terabit per second, 100 times improvement in energy efficiency, and positioning so precise it knows where you are down to 10 centimeters, not just a few meters. This isn't just an upgrade, it's a complete teardown and rebuild of what a network can be. So a network that can do all that, how on earth do you even build it? It's pretty clear you can't just stick some new antennas on the existing cell towers. Nope, you have to completely rethink the entire architecture of how we connect the planet. The big idea, the grand vision for 6G, has this pretty wild name: the Space, Aerial, Ground, Sea Integrated Network, or SAGSN for short. The mission here is to create one single, unified network that gives you seamless, incredible performance literally anywhere on Earth. We're talking from the top of a skyscraper in New York City to a submarine research vessel in the middle of the ocean. Think of it like a 4-layer cake of connectivity, where every layer works together. You've got satellites up in space for that planet-wide reach. You've got aerial networks, drones and balloons, for flexible, on-demand coverage. You've got the ground-based cell networks we're all familiar with, and you even have an undersea network for ships, subs, and sensors. The really revolutionary part? They all talk to each other and work as one single cohesive system. So, we've got the vision, but what's the actual tech that makes this magic happen? Well, the whole concept of 6G is banking on a whole suite of revolutionary technologies, and honestly, a lot of them are still being cooked up in research labs as we speak.
Okay, the single biggest game changer here is opening up a whole new part of the airwaves. 6G is designed to move into what are called terahertz frequencies. These are way, way up on the electromagnetic spectrum, sitting right between the millimeter waves that 5G uses and infrared light. It is a vast, untouched wilderness for wireless data. The analogy here is pretty perfect. If the wireless signals we use today are like packed city streets during rush hour, then the terahertz band is like a brand new 100-lane superhighway with no speed limit. It's this enormous, untapped bandwidth that makes those crazy terabit per second speeds even theoretically possible. All right, this next one is really cool. The plan is to literally make our environment smarter, to turn it from a passive problem into an active part of the network. Right now, in our dumb world, a Wi-Fi or cell signal hits a wall and just gets blocked or scattered. But in a 6G smart environment, that wall could be coated with something called a reconfigurable intelligent surface. This RIS can actually catch a signal and intelligently redirect it, like a mirror for radio waves, bending it around a corner to get rid of a dead spot. And finally, we're taking a piece of tech from 5G and putting it on steroids. I'm talking about MIMO, which stands for Multiple Input, Multiple Output. Your 5G base station might have a few dozen antennas. 6G's ultra-massive MIMO imagines using hundreds, maybe even thousands of tiny antennas all working together. This lets the network create these incredibly precise, laser-focused beams of data sent directly to your device, which means huge gains in both speed and energy efficiency. So we've got the mind-bending specs, we've got the futuristic tech, but what does this all mean for you and me? What does life feel like in a 6G world? Well, this is where the whole thing really moves from engineering into the realm of pure science fiction. You know all those sci-fi movies with the holograms? Well, forget grainy Zoom calls. 6G could make that a reality. We are talking true holographic telepresence, projecting a full-size, high-definition 3D image of a person into a room with you in real time. Now, the amount of data needed for this is it's astronomical. A single holographic stream could require over 4 terabits per second. That's a speed that only 6G could even dream of delivering through the air. And if you thought holograms were sci-fi, buckle up, because looking even further into the future, 6G is seen as the critical missing piece for wireless brain-computer interfaces. These are systems that can translate your thoughts directly into digital commands. For something like that to work safely and instantly, you need the absolute best reliability and that near-zero latency that 6G is promising. And finally, let's bring it all together. 6G could be the final piece of the puzzle for creating truly autonomous cities. When you combine that massive connectivity for every single vehicle and sensor with that centimeter-level positioning accuracy, you get the incredibly robust and reliable digital backbone you need for fleets of self-driving cars, delivery drones, and robots to all operate safely together. Okay, holograms, brain links, robot cities, it all sounds amazing. But we need to take a big step back to reality here. As exciting as this all sounds, the road to actually making 6G happen is paved with some of the toughest engineering and financial challenges we have ever faced. And seriously, the list of problems to solve is just monumental. Remember those super fast terahertz waves? Well, they get blocked by almost anything. Rain, a wall, even just the air itself over long distances. Those thousands of ultra-massive MIMO antennas, they're going to consume a staggering amount of power. And those smart surfaces? Right now, they're experimental and way too expensive. And that's all before you even start to think about the trillions of dollars in investment and the global political agreements needed to build this thing. So, where does that leave us? Well, the journey to 6G is really just beginning. The technology promises to completely erase the line between our physical and digital worlds, creating a planet that is truly, deeply connected. The engineering challenges are immense, for sure. But the potential is maybe even greater, which leaves us with the biggest question of all. Once we build this all-encompassing network, what kind of world will we choose to create with it?